We're going to look at chapter 9.5. We're going to skip 9.4 and we're going to move on to 9.5, the binomial theorem. We're going to take this in two sections because I don't want to give you any homework over the break, so we'll just get halfway through the lesson and then we'll stop for the day. So we'll talk about what the binomial theorem is more next class than this class, but we'll introduce it this class. So we're going to look at how we can use it to calculate binomial coefficients. We'll explain what all that means. We're going to talk about Pascal's triangle, and we'll talk about what that means, and how to write binomial expansions. We'll just start to look at that, but we'll cover it more next class. All right, Pascal's triangle, developed by the mathematician Blaise Pascal back in the 17 or 1600s. Looks like this, where we have each row starts with a 1 and ends with a 1, and each element is composed of adding the two elements above it together. Now, when we talk about Pascal's triangle, we talk about the different rows, but you have to remember, this is the tricky part, that it starts with row 0. So this is the 0th row, and then this is the first row and the second row and the third row. And then we also talk about starting with the 0th element. So this is element 0 and then element 1. So element 1 of row 2 would be the number 2. Element 1 of row 3 would be 3. And so we have that nice pattern. Now, to calculate each of the other elements, here I've got 2 plus 1 is equal to 3, 3 plus 3 is equal to 6, 1 plus 3 is equal to 4, 4 plus 6 is equal to 10. Here I've got 15 plus 6 is equal to 21. And we could go on infinitely downward from this. But for practical purposes, we'll probably only use 7 or 8 rows of this triangle. But if we know the first couple elements, we can figure out any other element in the triangle. But it will help us to use the binomial expansion theorem, which we're going to do in a little bit. So, examples: use the 5th row of Pascal's triangle to generate the 6th row and find the binomial coefficient. So that means the elements. The 6th row, element 1, or we could do it this way, 6th row, element 4. These are two different ways of writing the same thing. So from the previous slide, row 5 looks like this one, 5, 10, 10, 5, 1. You'll notice that it's symmetrical. It starts the forward and backwards the same way. So row 6, we can calculate it this way. 1, and then 1 plus 5 is 6. 5 plus 10 is 15. 10 plus 10 is 20. 10 plus 5 is 15. 5 plus 1 is 6. And finish off with just 1 at the end. So again, it is symmetrical. It's same forward and backwards. Now, this would be the 6th row, the 0th element, 6th row first element, 6th row second element, and we could go all the way down the line. Another way to write that, 6th row 0th element, or here the 6th row 5th element, we could write it either way, but its value would be 6. So 6th row first element would be 6. 6th row 5th element would be 6. Well, if we looked at this, the 6th row 4th element is 15, and the 6th row second element is 15. So we found all these, and you'll notice that since it is symmetrical, that this one is equal to this one one's equal to this one. A general way to say that is the nth row rth element is equal to the nth row n minus r element. So here I've got 6, 4 is equal to 6 minus 4, which would be 2. So 6, 4 is equal to 6, 2, and that's 15 in this row. So symmetry. All right, let's switch over to the in-class practice and take a look at those real quickly. So find the terms of the third row of Pascal's triangle. A little light there, but I wrote it down for you. So here's the 0th row, first row, second row, third row, 1, 3, 3, 1. Find the terms of the 6th row. So 0th row, first, second, third, fourth, fifth, sixth, 1, 6, 15, 20, 15, 6, and it looks like the 1 got cut off there. Find the 4th row, third term. So here's 0, 1, 2, 3, 4, and here it gets 0, 1, 2, 3. So 4th row, third term would be 4. So 4th row, third term would be 4. 6th row, fourth term. So here's 0, 1, 2, 3, 4, 5, 6. 0, 1, 2, 3, 4 would be the 15. And 6th row, fourth element would be 15. All right, switch back here. All right. So binomial theorem, and we'll talk more about this next time. So if you don't quite get this all down this first time, that's okay. We'll go in much more detail next time. But if I have two terms, x and y, and I want to take x plus y to the nth power, I could write it this way, and we'll show what this means. But you'll notice that we're going to be using Pascal's triangle to help us figure out what this expansion is. So the coefficient of x to the n minus r, y to the r, is going to be the nth row, fourth element. And I could figure that out mathematically this way. N factorial, remember factorial means 1 times 2 times 3 times 4 times all the way up to n. Here's n minus r factorial and r factorial. So we could figure it out mathematically, or we could figure it out from Pascal's triangle, or this notation here. Well, how does this help us? Well, let's take a look at an example here. So binomial expansions. So it's a useful method of raising any binomial to a non-negative integral power. And we'll talk about what that looks like. So I want to figure out what x plus y to the nth is equal to. Well, x plus y to the 0th power, anything to the 0th power is just 1. X plus y to the first power, well, it's just x plus y. X plus y squared is x squared plus 2xy plus y squared. To the third power, x cubed plus 3x squared y plus 3x y squared plus y cubed. And the fourth, and the fifth. And you'll notice that these coefficients start to look like Pascal's triangle, and each term, each expansion has n plus 1 terms. So to the 0th power equals 1 term. Here to the first power is 2 terms. And you'll notice that these coefficients look like the values of Pascal's triangle. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. And you'll notice also that the x terms go in descending order. So here I have x to the 5th, x to the 4th, x cubed, x squared, x, and x to the 0th power is just 1. And the y terms go in ascending order. So here's y to the 0th power, which is just 1, y to the first, y squared, y cubed, y to the 4th, y to the 5th, and so on. And we will go into much more detail next class to explain that. I didn't want to have you to have any homework over the break, so we're going to stop there, and I'm going to let you have the rest of the class period. So if you have any other homework that needs to get taken care of, you have that opportunity to do that now. So this is where we're going to stop.